Okay, so what we're going to do today then is we are going to try to get through the majority part of a flight plan. So we're going to start kind of looking at it step by step as to what we do from the beginning to the end. So we're going to just start from scratch. We're going to pick a city pair, and we're going to pull up the NOTAMs, the weather, all of the runway information, and we're just going to use current conditions that we have, right, whatever they are right now as we speak, wherever we pick. And then we are going to basically start the preparation process of how we walk through a flight plan from beginning to end. We probably won't get through the entire thing today, but we're not necessarily meant to, as far as with all the steps and stuff involved, and this being a little bit of a shorter class potentially. So anyway, so that said, we're going to bring up Sky Vector and get ourselves a city pair and a weather packet. So anybody got any clever ideas on where we would like to fly today?
Do a long one.
East Coast, West Coast, surprisingly.
For the most part, we stay Denver and West in the class, for the most part. Might have a surprise one here or there. But that's where all of our charts are. Like if anybody got into the JEP chart folder that I added in there, you'll notice that for the most part, we try to use those cities.
Is there any weather going on anywhere up the East Coast or the West Coast?
You know, I haven't seen actually.
Nasty weather.
San Francisco's doing pretty good.
Hey, delivery.
That was fast.
Hi.
Who's on?
We have any?
So funny.
George, you think us?
Hey, you're handed it.
George?
Yeah.
Finally made it through this.
I just had
I did go to check this way, so make sure.
just had pizza guy show up.
No problem.
I think we should go from Phoenix.
Finally, Tyler gets in on the food action. Yeah, Christy, this class likes to order food.
That's impressive.
Everyone's looking at whatever they want. Dang, I wish I didn't just eat them.
I
I had a salad and I'm gonna ruin it with some pizza.
Yeah,
And for successes, no.
I missed lunch today. Well, not really. Man, it was not so gross, but.
Let's see here.
Yeah, chicken with Alfredo sauce.
As far as this first flight plan goes, you're really not going to want it to have weather.
Too crazy.
Yeah. Weather we will introduce as we get more into it, a little bit more. But anyway, even if we wanted to, there's really not much going on out there from what I can see. This is what we're looking at. It's going to be pretty hard to find some weather when you look Denver going to the west. So anyway, that's probably a good thing though. So
I'm cool with it.
what? Just throw whatever out you guys want.
Seattle to
Phoenix.
Okay, Phoenix to where?
Seattle.
Phoenix to Seattle. Okay, I can do that.
Or whatever's in Montana. I don't know. If even do like Boise or something.
Don't we fly like right to Glacier National Park?
Yeah, we do.
Let's do that.
That's Kalispell. Let's see here. Christy finally is in here. Just missed out on the pizza delivery, Christy.
Missed out on the what?
Well, there's another Christy, I should say.
Oh.
Sorry.
What?
There's a Christy online, and then there's Christy in class.
I was gonna say, I was like, she's been here the whole time.
Yeah.
Didn't miss the pizza delivery.
I said Christy. Oh no, you just walked in.
I just logged in.
Wait a minute.
I was like,
Crystal.
Crystal. Yeah,
Crystal is
that
in
just
here.
threw me for a loop because they have the same last name too.
Weird.
Yes.
You mean Crystal Jones?
Yeah.
Oh, that's why I was messing it up.
That would be confusing.
Yeah. Anyway,
That's awesome.
That's why I was just looking at Jones and I was thinking Crystal Jones just logged in, but no, she is still not in. It was you though. Yeah, that makes it even crazier. Anyway, so, okay. So, that's what we're looking at. Not much going on. So, let's hop on out of this and go into this. And we will go Phoenix and Seattle. Okay. Phoenix to Seattle. And then, just in case, we're going to throw Portland in there, and we'll just leave Portland as a potential alternate in case we need one for Seattle. Okay? Okay. So, let's see what we want here. Don't really want that in there yet. Don't want air mats. Okay. Any military, international, or Canadian. Don't need snow tams. Don't need surrounding stations. Okay. Display. Station IDs. Get our PDF here. Okay, so what happens with every single flight plan is you are going to be handed a weather packet. First of all, you're going to have your flight plan packet, which I'll show you, and we'll start kind of walking through today, but then you're also going to have a weather packet, which is going to be this, basically. And it's going to have all of your information that you need. It's going to have all of your origin weather, all of the, the METAR, the TAF, the NOTAMs, the pi reps, anything for the origin is going to be on there. And then it's going to have, obviously, your destination information, all the same stuff, METAR, TAFs, NOTAMs, and then anything for the alternate as well, all the weather and NOTAMs for your alternate. So Crystal is now on.
Oh, there she goes. Yeah, Crystal.
So the other thing that you're going to get is, so you're going to get this weather packet. Along with this weather packet, you're going to get, do you remember that list of aircraft that we have that we use in the class, the 10 different airplanes? You're going to be assigned one of those 10 airplanes. I'm just going to put the tail number on there, okay? And then with that tail number, you'll just know that that's the plane you're going to be using. So when you need to do weight and balance and all that stuff, you're just going to reference that tail number, and you're going to go and you're going to look at what the bow weight is, the base operating weight, and the index. So you're just going to pull it from there. And then I'll give you the passenger load, the bag load, cargo, kind of like when we were doing the weight and balance. I'll give you all of that information, basically. The only thing that you have to do with that, obviously, is you're going to have to run through the weight and balance stuff on your own. You also are going to be the one figuring out the fuel load as well. Like when we were doing the weight and balance examples, I just gave you a fuel load. But now we're to the point where in flight planning, we are going to be figuring out the fuel. This is where now kind of we're going to be doing that. We're going to figure out what the actual fuel burn is and all of that stuff. So, So the first time we roll through this, it's probably going to be pretty confusing. It's probably going to be a little, too much to probably take in all at once. But the big thing here is what you want to do is kind of take notes to how we roll through the steps, basically, because the one of the biggest key to the flight planning stuff is really just kind of knowing the steps. And if you can get the steps down and kind of have like a checklist of sorts to kind of know, like, okay, this is what I do first, this is what I do second, and then kind of, little reminders at certain points that you want to check something, because the thing about going through the flight planning is that you have a lot of kind of cross-referencing and cross-checking that you have to do, and you have to figure out a fuel number, and then you got to compare it against some of your other stuff, and sometimes you have to make little changes as well as you go along. So that's kind of the way it'll work, but and you'll see kind of exactly what I mean. But we're going to go Phoenix to Seattle. Okay, so the next thing that we're going to do, I am going to bring up a blank copy of the flight plan packet. So as this loads, I'll put it on that screen for you guys to see here. Okay. All right. So this is the flight plan packet. So this is page 1. It's the dispatch release page. And as we move through the steps of the flight plan, you go through basically filling this stuff out. This front page here, or this first page, so there's 9 pages total here, but this first page is really one that, other than the basic information, you actually want to fill this one out at the end, at the very end, because this is what contains the final numbers, your final calculations, okay? And these are going to be the official numbers, essentially. So as we go along, there's this map here, which this map is just kind of more for your use here. Go in here, rotate it. Anyway, so this is if you wanted to like plot like sigmets or something like that on it, you could. For the most part, though, in the weather packet, I usually will give you a kind of a graphical map of like sigmets and weather and stuff for you to look at, or at least to have on your computer that you can kind of zoom in and out of. This also, I mean, you can kind of use it for whatever you want. You can, if anything that you might find it useful for. Some people don't use it at all. You don't necessarily have to use it. I'm not sure. Did you ever use this, really? So it really just depends. But it's there. So that's page 2. Page 3 is our IFR flight plan page. Okay, this is going to be, we write in our origin, destination, alternate, the filed route, the written out filed route. Then all of this stuff in here is going to be where we put each leg of our burns, like of our fuel burns, and do all the calculations. So will make sense a little bit later. This is our performance worksheet where we go through and we do all of our, we put in our temperatures and like what flap settings and things like that we're going to use for takeoff, landing, for the origin, alternates, destination. it is all on this page. Also, our landing speeds are the runway we use for takeoff. All of that is going to be in here. Next page is, this is going to be basically our weather minimum, and this is the page where we list and figure out what our landing minimums are, our alternate weather minimums, where we do all of our calculations for that. Where we list like which runways we're going to land and which like approaches we're going to use. So if any of this is kind of sounding or looking foreign, it'll make sense. This page obviously you should be familiar with. That's where you're going to do your weight and balance. There's your list of aircraft. And then of course your passenger pin card, and then your index table. And that's the last page. Okay? So some of the stuff you've seen, some of it you haven't.
You're all supposed to seem pretty overwhelming right now, right?
Yes. 100%. How overwhelmed were you on the first time we went through the flight planning? Pretty overwhelming.
Yeah.
What about now?
I feel good now, but yeah, it was stressful.
But you catch on.
Yeah.
Okay.
Yeah, it's just repetition. I mean, we're going to do, 6, 7 flight plans over the next 2 or 3 weeks here. So, okay. So, let's go back to the list of aircraft. We're going to just figure out a few little things. I'm going to kind of just, it's always good to have even like a piece of scratch paper. You can also use, when you print these out, these flight plan packets, depending on how you print them, you can, always just write on the back sides of these pages for your notes or whatever you want, unless you just want like a blank piece of paper for note taking to do your calculations. When I'm doing it on the computer like this, I'm actually going to be like filling this all out real time, kind of like when we were doing the weight and balance and I filled it out with, typing it all in. I'm going to be doing that this time as well. At the end of the class, you basically need to have 5 fully completed flight plans to turn in, okay? So ones that we do in class are fine to use. The ones that I assign for you to do at home also as well are fine, just whatever. Your final flight plan that you even do in the class is fine to use as one of them as well. So what we're going to do is we're going to just make up some numbers to use and pick one of the aircraft. I'm just going to bring in this little Word document and just to kind of put like our little notes in here. So let's use 752 Sierra Kilo. That's going to be the plane we use. So going back into this, I'm going to just type in November 752. Oops, that's 852. 752 Sierra Kilo. 752. So you'll just see it. So when I give you the assignments, you'll just see the tail number, and then the next thing you're going to see is the amount of passengers. Let's just say let's just go with 63 adults and 3 kids. Okay? And then let's just say we have 100 bags. Okay? And we'll just leave it at that. Okay? The only other thing that I will give you, and sometimes with this stuff, sometimes I'll do more than that. Sometimes I'll put 500 pounds of cargo in the forward compartment, or sometimes I'll put a jump seater or whatever. You guys have already seen those when we've done those weight and balance stuff. So the only other thing that you get from me, information provided from me, is an estimated time of departure. Okay, and that's basically for us to use when we look at what time we're leaving weather-wise when we look at the weather stuff. Okay, so Let's go back to our weather packet for just a minute here. So 2351. We'll just say that our estimated time of departure is 0040 Zulu. Okay, so that's what we have to go off of so far. Estimated time of departure 0040. Okay, so what we want to do, first off, is when you've got your trusty sky vector stuff going on here, bring up your flight plan and just type in your origin and your destination. Enter. It's going to draw that nice straight line for you.
Do we use Sky Vector like on the
Usually, yes. However, as of literally 2 days ago, there was some new stuff sent out by the FAA, which I have to read through, and it talks about a restriction on electronic devices. So, I sent our FAA guy an email back to kind of get some more clarification, because it just says it's a restriction on any device that has an internet connection. So the way we use it, it wouldn't be acceptable. However, in an offline format, sounds like it would be. It's not so much a restriction on doing it on the computer, because it says that you can have a computer to do your calculations and the stuff that you'll see, your fuel burn calculations. You can actually use a flight computer for that. Or we sometimes have apps on our phones that do the same thing as a flight computer. It just says it can't have an internet connection. So the clarification that we're trying to get is, because I talked to Greg, who's the examiner, immediately, and we were both like, what do you think that means? Anyway, so we sent Jeff Gilmer, our FAA guy, the guy that you guys met on day one. That's the guy who really makes this decision. Kind of the clarification, if we have it in an offline mode, like the charts available offline, and like an app, as long as verified that like your cellular data and your Wi-Fi is turned off or whatever, you can still use. Anyway, so that's what we're waiting back to hear. Worst case scenario, though, is that even if they said no to that, the thing about Sky Vector is that when you see these, you are actually seeing. I mean, this is the map. Okay, this is all of the charts that we have. These are the charts, and all of Sky Vector is just a picture of these charts, just meshed into like a more usable format. Obviously, granted, it's obviously a lot easier to do it on the computer and type in information and have it draw lines for you. But if you were to take these and spread them all out and put them together, and you know how those planes match up to where you can make it so that you make sure you have it all correct. It just simply takes a little bit longer to do it manually. So the thing is the possibility always exists that you would have to technically use the charts even in the practical, even before this email came out, because if the FAA guy decides to come and sit in on one of the practicals, then more than likely he would have you use the manual charts. Like when I did mine, it was all manual, and that several of my students over the years have just had him randomly show up, and they had to do this. Now, when they first thought about that, and them having used Sky Vector the entire time, it was kind of like a freak out type thing. However, the feedback from every single one of them was just, it took me maybe 15 minutes longer than normal, was their end result. Like it was nowhere near what I thought it was going to be. It just simply took me a little bit longer to do it because I had to look at this and figure out the route, because you're only looking at this The only thing we're using SkyVector for is to create our route. That part of the flight planning process is not very long. Everything else we're doing, like where we look at like the landing approaches, those are all manual charts. That's not going to make a difference for you guys whether you're looking at it on a computer or you're looking at it on a piece of paper. And in most cases, looking at it on a piece of paper is probably easier than scrolling through it on your computer. So those, when you have them printed out, it's really just this. It's the 10 minutes or 15 minutes that it takes to actually create the route and figure out what jet routes you're going to use. But once you're done with that, that part that's just like step one of like a whole bunch of steps. So it really doesn't make much difference in the end because everything else we do is manual. So the SkyVector portion of it literally just saves us maybe 10 or 15 minutes total. That's about it. So if that does happen, don't worry. It's really honestly not even a big deal. It's and we'll actually do one where I just have you use the charts too.
Okay.
So
That's cool.
it's really. Okay, so we've put our route up there. Or not, sorry, that's not our route. That's just the direct line between Phoenix and Seattle. So the first thing that we're going to do, the other thing, going back to the information that you get about the airplane and this stuff here, this is also where, and we're not going to have any MELs on this flight that we do, this first one that we do, but this is also where you will have your MELs. So your MELs will be listed with this information. It's usually just going to be page 1 of your weather packet, essentially. It'll be, the top page will be, it'll look like this, and it'll have your airplane, your passengers, your bags, your ETD, and your MELs. Okay, so once you see the MELs, I just simply list the MEL number, and then it's your responsibility to take that MEL number and go look it up and see what the restrictions are. Sometimes I do a little snippet, like a little, where I do the little picture of the actual MEL that you can just click on and bring up, but you still have to read through it and figure out what the stuff is, and that's just really saving you from actually scrolling through and looking it up in the book. That's all. So, but we're not going to have any MELs on this flight, so we know that we don't have any restrictions as far as MELs go. We know that we're not going to be, have an altitude restriction or a no icing restriction or anything like that, like weather, we already kind of looked at the weather. We can tell that it's probably going to be decent weather out there. But let's just go ahead and start. So the first things you want to know about the flight when you're, if you're kind of taking notes as to the steps, the very first thing that you want to look at after you see what aircraft you have assigned and take a look at your MELs, the very first thing you want to do is when you see the MELs, if you have any, you want to look up those MELs and just know immediately right off the bat what the restrictions are, okay? So, because if you have an altitude restriction, you need to know about it right off the bat. Or a no icing restriction, you need to know about it right off the bat. If you have an MEL for no icing, and then we start looking at our weather, and you see that we have, thunderstorms all over the western United States along the route that you're going to be flying, it should have major red flags, should be popping up. It should be no icing, and I'm going through thunderstorms. Remember, when we talk about icing, it's just simply any visible moisture present with a temperature of 10 degrees Celsius or less. Okay? So very easy to be in icing conditions, really. If you fly through a cloud at altitude, it's going to be icing conditions, because when you're at altitude, you only have to climb about a couple of thousand feet, and you're going to, even if you, on the hottest day here in St. George, where we're 110 degrees, which is close to about 48, 49 degrees Celsius, once you start climbing out of St. George and you climb, you lose 2 degrees per 1,000 feet as you climb, more or less. If you use that same little formula, it's, you get to 20,000 feet, 25,000 feet, you're going to be 10 degrees Celsius or below automatically. And then the only other thing you need is just a cloud, at that point. If you fly through a cloud, then you're in icing. So when you think about no icing, you literally have to fly the entire route without flying through any clouds. That's really what you got to think about. And that's pretty difficult to do. Sometimes we luck out and don't have the problems, but the biggest problem is going to usually be you're going to have to climb through them or descend through them at your destination. That's usually what the issue is. But so the only reason I'm mentioning that, though, is so that right off the bat, check your MELs, know what your restrictions are. Because if you have a restriction right at the beginning that's going to impede you from even operating the flight at all, you need to know that right at the beginning so that you can say something about it. Okay? The thing that you're going to learn as we go through the flight planning is that it's your responsibility to know as soon as possible if the flight is going to be able to operate or not. Okay? Now, sometimes it's going to be because of an MEL. Sometimes it's going to be because of weather minimums, like it's maybe the weather minimums at the origin are below our takeoff minimums and we can't even take off. We looked at a little bit on that last week with the takeoff minimums. Or if we figure out our route and stuff and then we figure out our ETA, well, if we don't have the landing minimums in the TAF at our destination at our ETA, same thing, we're not legal to go. We might need to delay the flight or we might not be able to operate at all depending on if the TAF ever has legal minimums. But this stuff we're going to look over, we're going to have several examples of these types of flights, over the next couple of weeks. You're going to get ones that have bad weather that aren't legal. You're going to have ones that have MELs that make the flight not legal. And it's really, you're going to learn it's your responsibility to say something about that as soon as possible. Okay? With this flight, we know there's no MELs. We haven't looked at the weather yet, but we know it's probably good. So we know from an MEL standpoint, we're good. So that's a big hurdle to get past at the beginning. So now that we know that there's no MELs and there's no problems with that, let's take a look at what the weather has to say here. Okay, so I'm going to zoom in here. Okay, so Phoenix. The latest METAR was issued at 2351 Zulu. Wind 300 out of 300 at 12 knots. Cloud condition is few at 12,000 feet, scattered at 20,000 feet, broken 25,000 feet. Temperature is 31 degrees. Dew point is -7. So remember when it has the M07, that means -7, so -7. Altimeter 2973, so that's good weather. 10 miles visibility, there is a ceiling, but it's at 25,000 feet. Okay? As far as the TAF for Phoenix, now the TAF really isn't all that important for the origin. Okay? The most important weather product for our origin is always going to be the METAR. That's the current weather, that's where the plane is sitting as we speak. So the METAR is always going to be the most important thing there. The TAF, however, if we care, still looks good. So even if we got into a delay situation or whatever, the TAF looks good for the rest of the day and evening. There are no SIGMETs. There's some PIREPs out there. Most of these are just informational PIREPs. They're just talking about the temperature and the wind at certain altitudes. Not really a big deal. Okay, so the NOTAMs we'll look at. We're going to circle back to those in just a minute, though. We've looked at Phoenix's weather. It's good. We know that now. We're going to skip through Phoenix NOTAMs real quick, and we're going to go down to Seattle's weather. Now, we haven't figured out our flight plan, obviously. We don't necessarily know how long this flight is yet, but just from simple guesstimation of what you know of the geography of the Western United States, how long do you think a flight from Phoenix to Seattle is? Hour and a half, you say?
I say, yeah, I
3
say 2.5.
almost, yeah.
I'd say 2.5, 3. That's probably where my guess is. 2.5, 3. But anyway, it's not like you need to guess that down, perfectly at this point. The only reason I'm even having you think about it is just because when we look at the TAF, depending on how the TAF is divided up, you'll be able to you can start looking at the TAF, so we're leaving Phoenix at 0040. Let's just say it's 3 hours, okay? Let's just say our flight's going to be 3 hours long. Okay, so if our flight is 3 hours, that would mean an ETA into Seattle at roughly 3:40 Zulu, right? 3:44, somewhere in there. Okay, so that's just going to help you a little bit kind of look at your TAF, right? So you see that there is a from line in the TAF starting at 0300, but it says, wind 030 at 6 knots, greater than 6 statute miles, skies clear. Okay? The one before that, just in case our flight is shorter than 3 hours, the one before that is also great. Wind 350 at 7 knots, greater than 6 statute miles, skies clear. Now remember, greater than 6 statute miles, that's the best visibility you'll ever see in a TAF. So it could be, 100 miles visibility, but the best you're ever going to see written is P6SM. So that means it's the best it can be in a TAF. And then SKC, there's nothing better than that, skies clear. And that's the same line here. So the first time we even see any weather at all is right here. But what time is this?
13, 16.
Yeah, from 13 Zulu to 16 Zulu. Now, just without knowing our route, obviously, we know for an absolute fact that this is not a 13-hour flight, right? Okay. So just by simple knowledge, we know that our ETA is going to fall somewhere in those two lines, right? And that next line below, which it does get bad, it gets down to 2 miles. It gets down to needing an alternate right there, but we know that is way out from our ETA. So it's not even in our ballpark of even caring about. So we know that that's what we care about, and all of what we see there is absolutely awesome weather. Okay, we know we don't need an alternate. So there's just the reason we're kind of looking at this right now without even figuring out our flight plan yet is just knowing ahead of time. You already know you're not going to need an alternate. So those are some of the big things, knowing that you don't have any restrictions on your MELs, knowing that, you have great weather at your origin and great weather at your destination. You don't need an alternate. Those are some of the biggest factors in the flight that you have to know about and get right, essentially, every single time. So, great weather. So we're not concerned about anything weather-wise. we know we have our landing minimums. We know we're legal to go. We know we don't need the alternate. We know that we don't need a takeoff alternate as well. Back in Phoenix, weather was great there. 10 miles. So no takeoff alternate, no destination alternate, no MELs. So those are the things so far.
So at the origin, you're checking the METAR, and then your destination, you look at your TAF.
Yeah, because even though right now in Seattle, this is our METAR. METAR is only a representation of current conditions. So, if 3 hours from now, this is, when we're looking down in the future, this is the most important weather product that we care about. So, but even currently, the TAF is good, or the METAR is good. So things are looking good. Now we know all of this so far. The only other thing that we are now kind of caring about, weather-wise, we know we're good. We just want to make sure. Now we're going Phoenix to Seattle. Those are both big hub airports. They're both going to have several runways to choose from for both takeoff, landing, anything that we need. So the only thing that we need to care about now, we want to start taking a look at our NOTAMs. And anything you see from a NOTAM standpoint, you want to, notate. So, okay, if I see that one of the runways is closed, I just want to notate that. So when I go to select a runway, I know to disregard it. Now, the other thing that you know about, now that we've already looked at the weather as well, when we start scrolling through these NOTAMs for Phoenix and Seattle, and we've kind of talked about the ones that we train our eyes to stop and look at, like the runways, the navs, different ones like that. We know most of those NOTAMs we only usually care about when the weather is bad. Okay, that's when those NOTAMs play a bigger role. When the weather is great like this, when it's VFR weather, those NOTAMs almost have zero significance to us. You could have every single ILS in Seattle and Phoenix out of service, we wouldn't care less because we're not going to need them for this flight. We're going to have, we're expecting greater than 6 statute miles, skies clear at arrival, and taking off in Phoenix, same thing, great weather. We don't care, essentially. That's why we look at the weather first, because the weather, knowing the weather is going to know how much we care about the NOTAMs. Okay, so we're still going to look at the NOTAMs, but the only thing we're really going to care about NOTAM-wise at this point is really just whether a runway is closed or open. So it's some of those NOTAMs that we train our eyes to stop and read aren't going to have as much significance. So let's start looking at Phoenix NOTAMs. First one is an obstacle NOTAM. Obstacle, don't care about those. Taxiway, runway. Okay, so Phoenix, runway, 7 left and 25 right is closed. And that is from September 27th, 2017, 0600 Zulu to September 27th, 2017, 1400 Zulu. So is this in our ETD window at all?
No.
So our ETD is 0040 on the 27th now, because today is the 26th, right? So our ETD is the 27th, but it's 0040. So this is essentially 4 or 5 hours after we take off. So we don't care. A lot of airports actually close their runways like this. So you see that this is 7 left, 25 right. It's closed from 6 to 1400. And then the other one, 7 right, 25 left, closed daily from 500 Zulu to 1300 Zulu. So those are typically just the hours that there's no flights going on at those airports. So they close down the runways. So, but that's common to see these, but make sure that when you do see them, to make sure you check the times, because most hub airports during those off hours in the middle of the night when they don't have any flights coming and going, they will close down all of their runways except for maybe one that they just need to keep open for random whoever's coming in delayed or whatever, Okay. So 7 left, 25 right's closed, but it's not in our departure window, so we don't care. Taxiway, don't care. Taxiway, we don't care. 7 right, 25 left, same deal. 500 Zulu, 4 hours after we leave, we don't care about that one. Taxiway, obstacle. Scrolling down here, don't care about any of these. Taxiway, apron, taxiway, obstacle. And so there's that. Remember how we talked about this AD? So Phoenix Aerodrome Airport closed to touch and go, stop and go ops, except written prior permission from airport ops. Okay. Does anybody know what touch and go is? John knows. Yeah, you immediately take off. This is mostly talking about student pilots that are practicing landings and takeoffs. We don't have any of our flights that do this. Our passengers don't necessarily like it. So this is really just applying to those small little prop planes with student pilots. This is a big hub airport. They don't have time to have little dudes and Cessnas practicing. We've got 747s coming up on their ass. All right. So that doesn't mean anything to us. Okay, now we're into FTC NOTAMs. Now, regarding FTC NOTAMs, just a quick refresher on what is an FTC NOTAM.
Approach, interruption.
Instrument procedures. Not necessarily approach. It can be approach, but any instrument procedure, SID, stars, or approaches. Now, with that said, knowing that we don't have any bad weather, knowing all of what we know so far, and knowing that FTC NOTAMs really just affect instrument procedures, do you think that there's really a huge need to start rolling through these and reading them? The only thing that there might be in these FTC NOTAMs at this point, it would be it telling us that one of the SIDs, because now obviously this is Phoenix, we're departing, so we'll be on a SID. If one of the SIDs is not authorized right now to use in our planning, that would be pretty much the only thing that we would care about in Phoenix, because we know the weather's good. So if they have, so let's just start looking at them real quick, just to know, because if they have a SID that's closed down that they don't want people using, we want to make sure we don't, as dispatchers, go and file our people on that SID that's not supposed to be used at that point, right? That'd be the only thing. So this one is talking about ILS or localizer runway 7 left. Okay, so that's not a SID. This next one is the Maxo 3 departure. So that is a SID, okay? This is saying Anton Chico transition is not authorized except for aircraft equipped with suitable RNAV system with GPS, which is us. So then that makes us not care because we do have suitable RNAV GPS. Okay?
I thought we weren't using RNAV on our flight plan.
We don't use it,
Yeah.
but we have it.
Okay.
Yes. It is installed. So, but yeah, you wouldn't be using a SID that's RNAV though in the first place. The next one, Phoenix Star, the Cooley for arrival, procedure not authorized. Okay, that's an arrival, we're not arriving. The next one, the Mayor 5 arrival, not authorized. Same thing, don't care. The next one is the Gila 6 arrival, don't care about that one. The next one is a SID, the Silo 4 departure, not authorized. So just write that down, the Silo 4. I don't even remember which direction the Silo 4 goes, but if it goes the direction we want, we can't use it, okay? So mentally noted. And then lastly, ILS runway 26, okay? We don't care about that because it's an ILS, which we don't need. Okay, so that's what we know about everything about Phoenix. It's good weather. We can't use the Silo 4 departure. Everything else, good to go. So no runways closed. We should be good. Okay. So what we want to start doing is slowly start kind of filling out this packet here. So we will just use today's date. Just go 9/26. And you can put your own name as the dispatcher. Okay. This is the original release, so we can circle that. It is not an amended release. We always file IFR, so you can circle IFR there. This is going to be flight number 1. We know our aircraft number. It is November 752 Sierra Kilo, and it is from Phoenix to Seattle. We don't have a takeoff alternate. We don't have a destination alternate or a second one. Flight level is over here. We don't know that yet. We don't know our route. We don't know our ETD. Actually, we do know our ETD. Let's go ahead and put that in. 0040 Zulu. Did I write O's instead of zeros? 0040 Zulu. Okay. We don't know our estimated time en route. We don't know our estimated time of arrival or our true airspeed. We don't know any of our fuel. We don't know any of this stuff. There's no MELs. You can just write NA there. And that's all we know so far on the front page. Second page, that's that useless map thing. We'll come back to this in a minute once we kind of start figuring out our route. But for right now, we can go to this performance page, start typing in Phoenix as the origin. We don't know the runway or anything there yet. We're going to go and pick that here in just a minute. And a lot of this other stuff is we'll fill this in momentarily when we start picking our runways. Okay. So this is kind of where we're at right now. This is Phoenix, so you can go ahead and write Phoenix in right here. This is our scheduled time of departure, 0040 Zulu, and the weather at our scheduled time of departure is, just come back up here and look at your Phoenix METAR. We've got 10 statute miles. So a lot of times this doesn't necessarily give you enough room to write everything in. But the most important things to write in here are going to be your wind, your visibility for sure. If you have multiple cloud layers here, if you just have one, just write that one. Okay? If you have multiple like this, the one that you're going to want to go with is the one that represents a ceiling. Okay? So in this case, don't worry about few at 12,000 or scattered 20,000. Just write in broken 25,000. Write your temperature, dew point, and your altimeter. So 10 miles, or wind 30012. I'm just going to write 30012 knots, 10 statute miles, broken 25,000, 31 over -7. Then altimeter was, I think, 2973. Look at that, that's perfect. Okay. That's our weather at our scheduled time of departure. Now, that's always just going to be the current METAR, okay? Now, there's not going to be another METAR until like 0, because the last one was 2351 Zulu. The next one's going to be like 0051 or 52, 10 or 15 minutes after we're supposed to depart. So, unless something changes that would cause a specie METAR, significant change, which is definitely not forecasted, then we can expect this same weather at our departure time. That's why we're writing it in as is the current METAR. Okay, so let's go take a look at the Phoenix runway availability. Let's see. All right, check the chart folder. Down to Phoenix. Okay. Okay, that's our Phoenix Airport layout. So when just by kind of what you think would be common sense, when we're looking for a runway to take off on, what are the primary things we're looking for?
Headwind.
Yes, headwind. We want to take off into the wind. Okay. Anything else? Runway length. Runway length is always going to be more important for takeoff than it is for landing. We can usually pick the longest runway available for takeoff, and for landing we don't usually need all that much, so it doesn't really matter too much. We looked at the NOTAMs. We already know that none of these runways are closed. Okay, so this one here on the top is runway 8 and 26. It's 11,489 feet long. Going down here, we've got runway 7 left and 25 right. It is 10,300 feet long, and then runway 7 right, 25 left, 7,800 feet long. So just based on looking at those, does anyone remember what our wind is?
I think it's at 300.
300 at 12 knots. So at least from which side of these do we want to take off on?
Runway 26 on the right.
Yeah, 26.
Do you ever go off of where your gate is? Like, if your gate is, say, over here at 3, would you
Like right
still pick the, even though it's not very, I mean, it's 1,000 feet?
Yeah, if you know your gate, yeah. And now in real world dispatch, we have like a little ATC page that actually tells us which runways are being used. We also have on our Fusion screens, we can zoom all the way into the airport in most cases, and we can actually see the ground radar, and we can see what runways they're taking off on. So we have more tools, in real life. But yeah, typically Phoenix, but even within Phoenix, like all of these concourses up here are all American concourses. They a lot of times will still taxi their people all the way down here and take off on 25 right. And sometimes they go up here and take off on 26. So
it's not a huge deal to go across like that.
It's not a big deal at all, no. No. It just depends on what Phoenix happens to be doing at that time. But for our sake, for this class, since we don't use any of those tools, we're just going to pick the longest runway that's most into the wind. Okay, that's open, not NOTAM closed, things like that. So in this case, our best runway is going to be 26. And obviously, I don't give us, we don't have a gate assignment in here, so we don't necessarily know where we're parked. But we'll just plan on 26 because it's the longest, and all 3 of these runways are the same direction. So it's not, there's not a different runway that's more into the wind than any other. So we'll plan 26. We know it's open, so we'll plan on using it. So down here, we're going to write in runway 26. Okay. While we've got our jet charts up there, this next little part, while we're picking our runway for takeoff, we need, even though our weather is good, we still need to know what our takeoff minimums are for this runway in Phoenix. Okay, so we're going to look that up next. So remember, the takeoff minimums are on usually the page following the airport layout. You can see them all right here. So here is runway 7 left, 7 right, 8, 25 left, 25 right, and over here by itself is runway 26. So runway 26, what are the best possible takeoff minimums for this runway? Quarter mile. Okay, quarter mile is the best we can do. Now, if we were over here, if we would have chosen 2.5 left and 2.5 right, this one is the same thing. We can go down to a quarter mile or 1600 RVR. Now, just by looking at these two and comparing them, does anybody notice what the difference is here? Now, this says a quarter and this says a quarter, but what's the main difference between these two that like 2.6 does not have that this does?
RVR.
Has RVR, yeah. So these have RVR over here. So 2.6 doesn't have RVR. Okay, so quarter mile. So we're going to go back to this, and as we scroll over here, we're going to first put in what are our standard takeoff minimums. So if we go back and just look at that real quick, we're going to look here first. These are our standard takeoff minimums. And now remember, we're using the 1 and 2 engine here. So 1 mile is our standard takeoff minimums. So right here, we're just going to write in 1 statute mile. Okay, the next one is less than standard RVR. And then the one after that is less than standard visibility. So if we look at that, we have, that would basically be this category over here, which is our adequate visual reference, but it only goes down to a quarter mile. So, and once again, it doesn't have RVR. So in this next little category here, we don't have RVR, so we're going to have to put in not applicable on that one. And then, oops. Then on this one, less than standard visibility is just simply 1/4 statute mile. And then the next one over is if this runway had, if you remember seeing some of those other ones where we dropped all the way down to like the 300, where it just said like 555 or 333 or 666, whatever. That's this next section that it's asking for. Like, what are the absolute lowest minimums that we could go down to? Now, in Phoenix, they do not have those really low minimums. So you would think that a big airport like Phoenix would, but they don't. And it's more than likely the reason that they don't is because Phoenix is, generally speaking, usually good weather, right? The only time they ever have bad weather is when they get a haboob rolling through there that ever causes low visibility. You don't see fog there. You don't see snow, obviously. You don't see any of that stuff. So, and a dust storm, haboob, at most will only last usually 30, 40 minutes as it rolls through. You don't usually see multiple haboobies rolling through Phoenix. So anyway, so they haven't wanted to pay the money to put in one of those really low visibility systems. They cost a lot of money to install. So if they don't need it, then why install it, right? If they're only using it for like 1 day a year for 30 minutes, that's not really worth it. So they don't have it. So when we go back to this chart, all of this stuff is just going to be not applicable because they don't offer it. Now remember, that's just on runway 26. But even if you look at the other ones, now this is the rest of the runways. Even those ones don't have it. So it's not just a matter of where this runway just doesn't have it and these ones do. No runway in Phoenix has that. So, you know, if we were in a situation where we were taking off in really low visibility in Phoenix and we needed those really low takeoff minimums, then, you know, we would want to make sure that we selected a runway that could go down to those minimums, you know, in that case, in the future when you're looking for that. This next part is all the filing for alternate. We know that we don't need the alternate stuff. So anyway, so as far as Phoenix is concerned, we're good. This next number 2 down here is if we need a departure or takeoff alternate, okay? We don't need one, we don't have one, so you're not going to fill in anything down here. Number 3 is for our destination, and we'll put in all that information up here. And then number 4 is for the destination alternate. So we also know that we don't have a destination alternate either, so we're not going to fill in that. So really you're just going to fill in number 1 and number 3. So we know Phoenix now, we know the weather, we know which runway we're going to use, we know that there's no NOTAMs affecting us. Now let's take a look at Seattle. We'll just go ahead and at least type in the information. There's Seattle. If we go back into our weather packet here, let's scroll down into Seattle. We already looked at it once. We know that the TAF is looking good. We know that we're going to be somewhere in this area here. So we know that the weather's going to be good. The only thing we haven't looked at in Seattle is the NOTAMs. Let's start taking a look at them. So the first one is an airspace. It's just basically like saying that UAS is those like drone things. They're basically saying that they're not allowed in that airspace around the airport, which is a good idea. So the next one is nav ILS, so that's one that we normally read. 34 center glide path out of service. Does it matter though? No? Yes? No? Doesn't matter? Doesn't matter, right? Got great weather there. We're not expecting to have to shoot an ILS approach when we get to Seattle. Seattle nav ILS runway 16 center glide path. So it's the center runway, both ends, glide path out of service. And then Seattle runway 16 left, 34 right, closed, except 15-minute prior permission. That's the number you call if you want to get prior permission. And that is from the 27th at 0600 Zulu to the 27th at 1200 Zulu. What did we expect our ETD to be, more or less? 3-ish. Between 3 and 4Z, most likely. We certainly know that it's not 6Z or later, right? So this doesn't apply to us. Taxiway, not a concern. Obstacle and taxiway. So NOTAM-wise, nothing of concern. FTC NOTAMs. The only one that we would care about as far as FTC NOTAMs would be now if one of their star instrument procedures is closed. And this is talking about a departure. So this is talking about a SID, and we're obviously not going to plan on flying a SID in Seattle. So that one FTC NOTAM is of no concern as well. The next stuff down here is all for Portland. But Portland we just simply put on here in case we needed an alternate, and we don't. So, but it looks good if we did. Anyway. Okay, so that's Seattle, and nothing of concern in Seattle. So what we're going to do now is jump back into, well, let's go back first. Sorry for a minute, and look at the TAF again here. So if we're expecting to land somewhere, probably most likely in this line, we just want to get what our wind is at that time. 030 at 6 knots.
30 degrees.
Yeah. So out of the northwest a little bit. Is where, or sorry, northeast is where the wind is coming from. Okay, so now that we know the wind, well, first of all, let's just take this line here, and we're going to copy this line because that's the weather we can expect at our ETA. We will take the temperature and the altimeter up here from the METAR because the TAF doesn't give it to us. But when we go back into this, we don't know our true ETA yet, so we're not going to type in anything there, but we do know that our wind is going to be 030 at 6 knots, greater than 6 statute miles, sky's clear, the temperature was 22 over 13, and the altimeter was 3014. Okay. So with that, we're going to run back into Seattle. We'll take a look. Seattle. Scroll down until we get to the airport layout page. There it is. Okay, so can't really see it all. Anyway, Seattle. So which way do the runways run in Seattle?
It's,
Pretty much straight north and south, more or less, right? We're talking 160 degrees going to the south and 340. So we've got 3 runways, or 6 runways technically. 3, 4 left, center, and right, and then 16 left, center, and right. So what way was the wind blowing?
it's blowing to the south.
Yeah, so it's coming out of the northeast. It's coming out of this direction. So that means we want to land. Which end of these runways will we want to be landing on?
South. South.
Yeah, so we'll want to land heading north, right? So we'll want to land on the 3, 4s, one of them. As far as which one, doesn't really matter which one you pick, other than this is kind of this, at this point, it would just be more or less knowing what the airport itself likes to do. Just knowing the basics of planes that are taking off generally use the longer runways. So in Seattle, they don't necessarily want you landing on 3, 4 right because that's where everyone's waiting to take off. So 3, 4 center or 3, 4 left is probably what we'd want to plan for it to land on. But for our sake, we'll just say we're going to use 3, 4 left. So we'll jump back in here. We're going to come on down to here. This first thing that it's asking for is the runway, so we just type in 3, 4 left. We're going to go in to that same page that talks about the runways. Zoom in. So this is for runways 16 left, center, and right, and this one is for runways 3, 4 left, center, and right. Now in Seattle, you can see that they do have all that nice low visibility stuff for takeoff and all that jazz. So we're not taking off in Seattle, so we don't necessarily care about all of this stuff. However, what we do care about, though, if we scroll back up here to the top, if you find your runway, so we want 3, 4 left, which is right here, we just want to look at what it has. We can see it has RVR. This is the lighting that it has. It has a PAPI on the left side. See this little thing that says grooved right here? And then you see how that means that this little one with a circle, all 3 of these have that. That means that the runway is grooved. We've talked about that a little bit. It just means that the water, when it rains, the water falls into the grooves, rolls off the edges of the runway because the runway has some slope, on both sides. Anyway, that means the runway is grooved. And it answers this little question right here for us. Because this asks if the runway is grooved. So when we come over to here, you can put that it's grooved. I usually just say that if it's not grooved, you just want to put not grooved. If it is grooved, you don't need to mark it. That just means that it is grooved. So the only time you mark it is if it's not grooved, okay? The only time you really ever see not grooved runways is in Canada, because they don't groove their runways. So.
Did they do a different approach? Whether it's grooved, not grooved, or is it just
Not really, no. It just means in Canada that you have to pay more attention to standing water on runways and ice and contamination. All stuff that you learn about really more in the advanced dispatch, like once you get hired on with an airline. But yeah, we don't even do any Canadian cities in this class anyway. So, but there are some in the United States that don't have grooved runways as well, though. There's some smaller cities, and but it's not normal. So it's asking if it's grooved and if it's a headwind or a tailwind. So we already know that it's a headwind. The only time that we would be landing with a tailwind intentionally, okay, is if if you have an airport where you can only land going one direction. Some airports only allow you to land going one direction. So there's some situations where you're kind of forced to land with a tailwind because it's all you can do. The other thing is sometimes there's only an ILS approach to one end of the runway, and if the wind happens to not be favoring that end of the runway, but you need that ILS approach because the weather's bad enough that none of the other approaches are going to be good enough for you to land, but if you need the ILS, as long as the tailwind does not exceed 10 knots, then we can use it, okay? But we can't go anything over a 10-knot tailwind. So it is fine for us to land with a tailwind. It's just that it cannot be more than 10 knots. Sometimes we're forced to in order to use an ILS, so depending on what the weather is. But that's just an example. Now in this situation, it is going to be a headwind. So what we normally do here is we do a plus sign, meaning that it's a headwind. And then we put the amount of headwind. Now we haven't necessarily figured that out yet, but we know that it's 030 at 6 knots, and we're landing going 340, so it's coming in, it's kind of crabbing in from the right. So we'll figure out all of that stuff. I'll show you how to figure all that stuff out with, a little calculator thing and whiz-wheel thing that we use. But for right now, it's probably going to be, we can just throw in probably 4 knots. Yeah. It's not much. I mean, the wind's only 6 knots if we were going directly into it. So if it's slightly off to our right, it's probably 3 or 4 knots. So we'll just say 4. For this runway, going back into here, even though we have good weather, we're going to list the best available landing approach and with the best available weather minimums in this spot here. So what we're going to do, remember in this class, the best that we ever really use is an ILS. So what we want to find out is that if there's an ILS approach to 3-4 left. So I'm going to skip through all of the SIDS and stars here, down to where we get to the runways. Okay. So this is ILS or localizer 16 left. That's ILS localizer 16 center, 16 right, and here we go. ILS or localizer runway 34 left. We didn't see any NOTAMs saying that this was out of service, so we can't expect it to be available. We're going to skip straight down to what our minimums are. So what are our minimums for this runway that we plan on landing on Seattle? Half mile? 200 foot ceiling, half mile visibility. So there's your ceiling. And 2400 RVR or half mile. Okay, so let's go back to this. We're going to type in, it's an ILS approach. This next little part is asking us for the localizer or identifier frequency. Where you find that is on this same chart. If you go up to the very top, this right here is your frequency. So I don't really care if you put this in here or not, but if you do, that's where it's at. 110.75. The visibility needed is half statute mile. And there weren't any NOTAMs affecting that. Just write in not applicable.
If there were, you just put one note or something, like how
You just put yes, and then the thing is, though, is when there is a NOTAM, we normally don't even plan that approach.
Okay.
So if there was, then you probably wouldn't be listing it in the first place. So it's very rare to see anything but not applicable right there, because unless it's a one runway place, like if it's St. George and they've got a NOTAM for like the glide path being out on the LDA, then we'd be planning that same approach, except our minimums would be higher, and we wouldn't be putting half right there. We would be putting whatever it is, and then we'd put yes in the NOTAMs. And then normally you would go back to the front page of your dispatch release. Down at the very bottom, there's a remarks section, and you would talk about it right there. You would say, NOTAM for the runway, whether minimums are increased, whatever. So, okay, so that is where we're at to this point. So let's take a break, 10 or 15 minutes, and we will resume. Okay, so we're at this point here now where we've got runways figured out, we've got weather figured out, we know that everything's good to go, we know that the MELs are good, or lack thereof are good. What we need to do now at this point that we've selected runways and got most of our stuff figured out, we need to go in and build a flight plan that we're actually going to fly. We need to figure out what the fuel is. I'm going to show you a quick method on how to estimate fuel, and then we need to obviously run through, weight and balance. That part you mostly already know how to do. So, okay, so let's go, and we know that we don't have any limitations from a NOTAM standpoint other than the Silo 4 SID in Phoenix, can't use it. So let's go take a look at SkyVector here for just a second. Okay. So obviously we want to go to the northwest. So the first thing we want to find is, let's find a SID that goes to the northwest. So this is Seattle. Let's go back into the Phoenix. So the first ones are stars. So let's scroll down to where our SIDs are. Still a star, star. This one is a SID. Okay, so here's the first SID that we have. This SID, actually, yeah, that is a SID. Okay, so this one goes out to the west. It does have some transitions that kind of are going northwest, but this obviously is an option. This is the Buckeye 4 departure. So just remember that one for a minute. Let's keep going, see if there's anything better. We've got the Chile 4 departure, which that looks like it goes more northwest. Obviously, it goes to Beatty. If you remember the Beatty VORs, the one northwest of Vegas. So that's, so far that looks like probably the one we'd want, unless we see something better. There's that Maxo 3, which this one is going to the east, so let's not worry about that one. There's the Moby 4. That one kind of goes more to the south So here's that silo 4, the one we know we can't use, so skip that. And then here's the St. John's 8, which if we flip that around, it goes to the east. And this is the Stanfield 4, which is also kind of more of the southeast. That's it. So it looks like that Chile 4 is probably the best. So let's go take a closer look at the Chile 4. Okay, so just kind of see how it works. So now when we're looking at our airport down here at the bottom, one thing to note is if you see the lines that come off of both sides of the runways like this, that basically is telling us that we can use either side. You know, like if we're taking off on runway 8 or we're taking off on 26, whatever direction. If you see that it only has lines going off of one side, that means you can only use it for taking off that direction. So if it only had the lines coming off of this east side, that means that we can only use it for takeoff on 7 left, right, or runway 8. So so that tells us basically we can use either runway. It also usually will list the runways here that you can use. But so this one is fine for runway 8 or runway 26 that we want to use because we're going to be taking off to the west, coming out this way, and then you can kind of see that this has some instructions here to climb. We're just kind of just briefly looking over it to see what it says, but it climb, and then it basically gives you instructions to meet up with basically coming up here to this Chile intersection. So this is one of those SIDs that has, it is a normal SID. It's not one of those radar vector SIDs that we can't use, but this does have a little bit of, kind of like that Vegas one, if you guys remember. The Vegas one, you had to go to that Sheed intersection and then go to Beatty. That's kind of like that, a little bit. It's, you take off and you climb, and then you turn heading 360, and ATC actually will give you instructions all the way up to Chile. We treat this as if it turns out and then just goes, like as if it goes from here direct to Chile. That's basically how we treat it. Unless you're taking off on going to the west, or sorry, going to the east, then you would actually take off and then you would go direct to this Zephyr intersection here. Mm-hmm. So you can also, if in case it gets confusing, you can also look at which runway you're using right here. So this says for 25 right and 26, it actually tells you the instructions. Climb heading 258, that's basically the runway heading, to 1,550 feet. Then climbing right turn heading 260. Once you get to 9 nautical miles DME west of the PXR VOR, which the PXR VOR is right here. So once, as you're flying away from this, when it says that you're 9 nautical miles away, you that's when you do a climbing right turn to heading 360. Then from right here, it tells you this is when it says routing here, this is applicable to all of these runways. So it says maintain 8,000 feet, expect radar vectors to the PXR radio 321, which is this radial. That's basically saying that you'll fly kind of a direct line and then until you intercept this radial, and then from there you'll turn and go to Chile intersection. So vectors to the PXR radial 321, to the Zephyr or PXR, so it's basically saying to this intersection, which is 40 DME from PXR, and then to Chile. So it actually says we turn and we'll actually file from here direct to this Zephyr and then the rest of the SID as it looks there. So that's the one we'll plan on using. I'll show you how we're actually going to write that out on the flight plan in a minute, because SkyVector is obviously not going to accept it like that. It's going to make us type it in manually because it won't probably read this SID, but we'll try and see if it does. But most likely, we're most likely going to take this all the way to this Beatty intersection. But let's jump in here and go figure it out. Let's start looking at kind of where it's going here. So now that Beatty VOR is over here. If we look at it in comparison to our direct line, is clear over here. I'm pretty sure that if we had that Silo 4 SID available to us, that ultimately that's probably the better one that we would have probably used in this case, because the Silo 4 comes straight and it has some stuff that comes off to the north, but it basically routes you up like this into these airways, which is going to be closer to the direct route. Instead, because it's not available, we're going to have to route over to here through these airways off that Chile intersect or that Chile departure. So not a big deal, but that's just the restriction that we're given because we can't use the Silo 4. So if we know that we're going to end up at Beatty, then we know from there that you can, from Beatty, it'll connect us to this J92. And I think we had that one that we did to Seattle the other day. So as you start kind of seeing the same cities again, in some cases, you'll start to remember, oh, I used one, and I think it was Tyler. I think, didn't you use the Olympia or something?
Yeah.
Going into Seattle? So you'll start to remember some of the stars. So the Olympia, I'm pretty sure what's going to end up happening is we're going to follow J92. We'll check this out, obviously, to Klamath. Yeah, or there's the Chin. Well, the Chins, I think, comes in off of the west because I think that connects to Pendleton or Kimberly. Yeah, but Kimberly is actually right there. So if we have a way to connect into Kimberly, that's almost right along that line. So the only problem is that it connects to this J523, which ends up going over this side, which we don't have a SID that connects us to any of these routes over here. So most likely we probably won't be able to use it, but we'll probably take it to Klamath, and then Klamath up to Battleground, and then Battleground up into Seattle. So let's take a look and see what Seattle has. So just real quick while we're on this, just remember Chile 4, CHILY 4. Sometimes that's just something you'd want to write in your notes so they don't have to keep going back into the charts to see what it is. So Seattle, we want one that comes up from the south. Okay, so the Frata, that comes off of the west. The Glacier comes off of the west. This Jawbone comes from the north. There's that Olympia. There's that Battleground. I'm pretty sure that's what we're going to end up using is the Battleground Olympia 2. There's that Chins, which has Pendleton, Kimberly. And then that one, the Elma, that's a departure. So yeah, it looks like that Olympia 2. The only thing I'm not sure of is, because remember these charts are from a few months ago, so the only thing we have to check is just making sure that's still what it's actually called. It might be the Olympia 3. It's still Olympia 2. So we're good there. And then Phoenix, that Chile, still Chile 4. So should be good. So it's looking like Phoenix, Chile 4 to Beatty, J92 to Klamath. Klamath, we end up getting onto J65. Actually, not J65, J189. into Battleground, and then Battleground Olympia to Seattle. So let's see if that works. The only thing I'm worried about is that Chile 4 because it has the radar vectors in it. I'm not sure if Phoenix will work. So CHILY 4. And that one we were taking to Beatty. Then J92 to Klamath to J189 to Battleground to the Olympia to Arrival. So let's see if that actually worked. Just trace it backwards. Looking good so far. There's Klamath. It's following J92. It's following it all the way up to Beatty. The only part that I'm worried about is all of this stuff down here where, okay, so that's the Chile intersection. So you can see what it does here. It takes us Phoenix direct to Chile right there, instead of going to that Zephyr intersection. So the only thing we need to do here is just we need to modify it so it actually goes to Zephyr. One way, there's two ways you can actually do that. If you go in here, you can actually just back out of this and just type in Zephyr without typing in. It should just know to go direct to Zephyr. Oh yeah, I forgot Beatty. Yeah, that's the one part that I forgot. Chile, then Beatty. Yeah, no, it doesn't want to do it at all.
It wouldn't work if you did Chile and then Zephyr.
If you want, you can actually take this and just drag it and drop it on Chile. If you drop it, it'll give you this option, and then it says Chile, and then you just hit plan. So now it has to do it. The only other problem, though, is that if you go back, the one problem that we get is when you take out the actual Chile 4 departure, it also probably is removing the rest of the stuff. So the Olympia side is fine. That's following it as it's supposed to. But if you pull this Chile departure back up, more than likely there's a whole bunch of stuff between Chile and Beatty that it's not figuring in now. Yeah, because it goes Chile. So when this happens like this, you end up having to type in all of this stuff individually, which this is where the SIDS and stars help us a lot, not having to do all this crap. So what we're going to have to do is we're going to have to actually go Phoenix direct to Zephyr, and then we're going to have to type in all of these Carlo, Chile, Ramsey, Sissy, Dovey, Beatty. So if anybody can remember those. Okay. What was the Zoom? KARLO? Then what? And then Chile, right? Then Chile. And then.
Remember, there's just a name, but no.
Actually, the other thing we can do, well, if it has these on here, which it probably doesn't. We just have to go back and look. So, Chile,
Ramsey,
and then Sissy.
W.
Then what?
W. D-U-B-E-E. I think that was the last one.
Okay.
Last class you're talking about doing the double dots and going straight from the airport to a VR.
Uh-huh. That's only, we're not using a SID. So only if you weren't using a SID would we do that. But in this case we are using a SID, so you have to follow the SID. If the SID's not working in SkyVector, then you have to type in every single point on the SID. That's basically what we did here.
Remember me last time why we didn't use a SID? Because there wasn't one?
There
Well,
wasn't
because there wasn't one in a quadrant.
in that
right?
quadrant, yep. Okay, so Zepper, Carlo, Chili, Ramsey, Sissy, W, Beatty. Looking back at this, Zepper, Carlo, Chili, Ramsey, Sissy, W, Beatty. Okay, that's looks good enough to me. Okay, so that is the exact route as it should be. The reason why we have to make sure all of those points are being connected in there, if we don't, we're going to have the wrong total distance, which is also going to give us the wrong ETA, which is going to screw up our fuel. That's why that is so critical. Most of the time the SIDs and the stars work in here. It's only when it's those radar vector ones that it screws it up.
Why wouldn't those be on this chart?
Those intersections, because this is a high chart. So, and Jaden just actually asked me the exact same question. He said, can't you just click and drag the line over instead of typing it? And yes, you can if it's listed. If it's on there, we could have done that. But the problem is the only one that was on there was, yeah, so Dovey's on there. The rest of them aren't on there except for Chili. Now you can go. The reason most of them aren't on there is because we're on the high chart. So if on the high chart, they have to be considered high intersections in order to be on the high chart. So if they're not, then they won't be. But we can check the low. It still keeps our flight plan on there. But if we look at the low chart, it still has Chili, but it doesn't have these other ones. It doesn't even have W. We can also go check the VFR chart, see if they happen to be on that one. Most of them probably aren't on there either. So yeah, they're on none. All of them aren't on here, regardless of the chart. So thing is when they're part of just a SID and a star, if that's all that they're there for, then they're never going to be on these charts. They're only going to be on the SID and the star chart. So the only reason Chili's on there is because Chili not only is used for part of this SID, it's also used as part of that J6. So they use it for more than just the SID. So what this tells us now is we have our total distance, 1,048.5 miles.
So, if you're doing this with actual physical charts, how do you know that?
Because you'll have the paper chart of the SID. So you won't necessarily be drawing a line on the charts like SkyVector gives us. What you're going to do you have to manually add up your distance.
Okay,
That's the biggest thing, is where this gives us.
So do you have to do like the whole this much?
Well, you have to bring up your SID first, and then you have to take care, and you got to add all of these on there. So you add those on there. Once that gets you to the other chart, so then you'd have to start at Beatty on the regular chart. So you come to the regular chart, you go to Beatty, right here. So you start looking at point to point. So from Beatty to Coaldale, right there, is 87 miles. You're right there in the box. So then you go from Coaldale to Mustang, and that's 127.
Suppose that's better than looking over.
Yeah. And then from Mustang to Klamath, I believe, is probably our next one, right?
183.
Yeah, 183. And then from Klamath to Battleground, it's going to be, see how it says 2 BTG right there? 219.
How big is the text on those charts?
You don't need to bring a magnifying glass, but if you need reading glasses, then you need reading glasses.
It's not too bad. I mean, I can show you. Well, here I have all the highs and the lows. Each one.
Is that the whole US right there, or is that just our?
This is just the West. But they're all the highs and the lows. So yeah. I've never been opened.
Crazy stuff.
No, you need like the entire classroom floors like
Yeah.
laid out on.
So that's Seattle. So
189 is where you were.
that's that 219. That's background right there. That's that 189. So we need the next one below it. But
Oh man. What a disaster.
I quit. Out here.
you guys want to see it?
I believe you. I'm so tired. I can't.
It's actually easier to look at it on the screen.
Until you have to like piece together.
Yeah,
like,
it's-
Yeah, if you didn't have to piece it together, it'd be better.
It's not that bad. They piece together pretty nicely.
Well, yeah, I just mean the space of it.
Yeah.
Just walking around it.
I guess you know like what section you actually what you need.
Yeah, you don't need to pull up the Boise or
Sometimes it's
Colorado.
So what about the city stars? Is there a charge for those too?
it'd be me printing what you see on the screen. That's all. Okay. So total distance 1,048.5. So what we're going to do at this point is we have our route now. Okay. What we want to do is just hurry and get that written down on the previous page, right here.
You write it down the same way you would have it.
No, that's just to appease sky vector. That's it. So right here, let's write this out. It's going to be Phoenix. In here, you're going to want the dot, Chile 4, dot Beatty, dot J92, dot LMT, dot J189, dot BTG, dot OLM2, dot KSE. So that's all you're going to put there. That's our route, though. So we've got that in there. Come back to sky vector for a minute. Now, we need to figure out, so now that we have a distance, we have a route, kind of got all that other stuff figured out, the weather, everything else is good, we need to start doing a fuel estimation at this point. In order to do a fuel estimation, we have to just use, we we're going to use some round numbers initially. So this next part is basically called your initial fuel estimation, okay? For this estimation, we're going to use an average speed of 400 knots. So now that we have our distance, we can actually figure out an ETA, okay? You can also, in SkyVector, if you're using this, you can just actually put your cursor up in here and you can just type in 400. Once you do that, it's going to give you this estimated time en route. 3 hours and 38 minutes. When we do our ETA, we always add 10 minutes for taxi out. So if our ETD is 0040, like it is in this case, we're going to assume that it takes us 10 minutes to taxi out to the runway. So when we actually add this part to it, this ETE is simply just the in the air time. That's all that is. It's not accounting for taxiing out or anything else. So really we need to add 10 minutes to that as far as our overall time goes to figure out our ETA into Seattle. So then this is, once again, this is just the initial estimate. So this is not necessarily our final fuel numbers. You're going to find that we actually end up having to calculate the fuel, like basically we do it 3 times. We do this initial estimate to kind of get a rough figure, and then we do what's called our simplified estimate, and then we do our actual when we actually go in and do the real calculations and figure it out. So this 400 number that we're using here is a little bit less than what we normally fly at. We normally fly more like 450, 460-ish. That's kind of the speed we're flying at. But this 400, this initial estimate, is not accounting for wind or anything like that. This is just simply straight up estimate. So based at going 400 knots per hour, this route that we've created, which is 1,048.5 miles, would take 3 hours and 38 minutes. So that 3 hours and 38 minutes, what we're going to do now is, for our initial fuel estimate, we use 4,000. So for the first hour, so this is 3 hours long, 3 hours, 38 minutes. For that first hour, we're going to say that it takes 4,000 pounds. And then every hour beyond the first hour is 3,000 pounds of fuel. So we're using, once again, kind of like that, we're using the 400 number. We're using these other fuel figures to kind of just get an estimate. So on average, the CRJ 700 burns about 4,000 pounds of fuel in the first hour on all flights as an average, okay? So we're going to kind of use that as a round figure, 4,000 and then 3,000 for every hour after the first hour. So if this is 3 hours and 38 minutes, how much total fuel is this looking like?
You just round up.
We'll just take whatever, that 38 minutes you mean?
Yeah, we just kind of round that up to.
No, we don't round it up. We just take exactly 38 minutes. So whatever 38 minutes is.
Or are we counting the extra 10 minutes in there too, or no?
No, because that's not airtime. That's just on the ETA.
500 about that.
Well, we got to get an exact figure. So so if we know it's 4,000, 3,000, so that last hour is the only one we really need to get a figure on, right? So 38 minutes out of 60, right? What percentage is that? 0.633 repeating. So all we got to do is just take 3,000 pounds, times it by 0.633 repeating. It's going to be 1,900 pounds. So if we take that, we've got 4,000 for the first hour, 3,000 for the second hour, 3,000 for the third hour, and 1,900 for that last 38 minutes. 11,900 pounds. That's our initial fuel estimate. Okay? That's the burn. Okay, that's this is not necessarily giving us what the total fuel is. This is just literally what it's going to burn in the air. So 11,900. So what are the other factors that have to be on the plane as far as fuel goes? 45 minutes reserve, right? So what are the 4 factors for computing fuel? Going back to your FARs.
And then fuel
Delay.
the destination, the furthest alternate, 45 minutes.
Yep. So do we need an alternate? No. So really this this initial fuel is kind of compensating for our wind and weather. The only other thing that we would need to put in here is, do we have any anticipated delays? And then you have the one instrument approach and a possible missed approach at the destination is auto-calculated in here. So the only thing that we're really concerned about is, does it need an alternate and are there any delays? So we know it doesn't need an alternate. It's great weather at both ends. There shouldn't really be any anticipated delays. The reason you have delays normally are due to weather. So nothing for that. So the only thing we really need here is to put in that 45 minutes of reserve fuel.
And then that's the approach, right?
Yeah, but that's already auto-calculated in with all of the fuel figures. So we never actually calculate that into it. The computer does it all, yeah. So the fuel figure, you're going to use this 45-minute reserve fuel number for all of your flights, but it's going to just be 2,500 pounds. That's your 45 minutes of reserve. So if we add that in, we're now up to 14,400 is what we're actually going to put on the plane.
I'm sorry, that was 2,500.
Yeah, 2,500 is the 45-minute reserve. Okay, so is there any other fuel we need to add on here?
Wind.
The wind and weather that's part of our 4,000 per hour. Well, actually, when we do the actual numbers, that is compensating for the wind, but this is just kind of the initial estimate here. So this is really just to be able to start doing our weight and balance. Okay, so 14,400. There's no reason for us to add like holding fuel or contingency fuel because we don't anticipate any delays en route or once we get to Seattle. We don't expect that to hold. So weather's great. Everything else is good. So we need all of our burn, which was that 11.9, and then our 2,500 reserve. And that's basically where you're getting this 14,400. So that's going to be our initial fuel estimate. So with that now, with having that initial fuel estimate, you should be able to go and do your weight and balance. So now we would be able to jump in and go do the weight and balance. So you can just put in all that basic information that we already have. Phoenix, flight number 1. Oops, that should have been the date. Don't have any alternates. Tail number right here, N752SK. Okay, so what were we, 63? 3 children, so 63 passengers. We're going to use summer weights because we're in summer. 11,970. Three, and then what? 3 at 82 pounds? What's 82 times 3?
84.
What's that?
84.
It would end in 6.
186? Or 2? It'd be 2,
Yeah.
2 something.
Oh, okay.
What is it?
246.
246.
Total is 12 to 16.
Twelve to 16. Okay, so this plane, 752, 44788 on the bow and 70.8 on the index. Okay, so now we just need to figure out where our passengers are going to be seated. So there's 66 of them. Just fill it up front to back, kind of normal. 12, that's going to be an index of negative 19.2. 12 again. Negative 13.9. C is negative 8.5. D is negative 3.1. This is 2.8, I believe. And then what? This is what, 8? No, 6. Right? Yeah, 6. 6 is 4.1. Okay, totals are 66. Everybody got that handy? Mathematicians out there?
I've got a calculator.
Great. That is a start. Negative 44.7, right? And then 2.8 plus 4.1.
6.9.
And then those minus each other.
Negative 37.8.
Okay, negative 37.8. So back to here. Okay. And the cargo. So what did we say? We had 100 bags?
100.
100 even. So bag weights, 100 bags is
3,000?
3,000 pounds. We'll just throw that all in the back. So aft cargo, 3,000 pounds. So we got 2970 or 3030. So we'll say 3030. That's 20.1. Okay, we don't have anything in the forward. We don't have an observer. So that's going to be 90.9. That. Right? Then 90.9 minus 37.8.
53.5.
53.5, you say?
0.1.
53.1. Okay, and then what's our total zero fuel weight?
60,004.
60,004. Does that exceed max zero fuel weight? Nope. Okay, good. Now our total fuel was 14,400, right? Which gives us an index of, so 14.5 is what we'll go off of, 0.9. Okay, and our total takeoff weight, 74,404.
Yeah.
And 53.1, so 54 even, right? On the takeoff index, okay? So coming down here, let's take a look at the zero fuel weight. First of all, 60,000 and 53.1. So 60,000 is here, and 53, let's see, 51, 2, 3, right to there. There's 60,000. That's zero fuel weight on that one.
Oh.
Okay. Takeoff is going to be 54, just right next to that, and then up to 74, right? Up there. Takeoff. And then just figuring out our landing index really quick. We know that we're landing with 2,500 pounds. So that's just our reserve, right? We're burning off 11,900. So that, going back to our zero fuel weight, 60 plus 2,500 is all we're doing there. So 62,504 would be our landing weight. Does everyone agree with that? Okay. 62,504. And if we're landing with 2,500 pounds on board, that's just going to be a negative 1.5. So 53.1 minus 1.5. So take us down to what, 51.6? So the landing index should be 51.6. So if we graph 62,504 and 51.6, so 51.6 is here, and 62,504 right in there-ish. So anyway, good, we're in balance. Everything looks good. Don't exceed max takeoff weight, don't exceed max landing weight, we don't exceed max zero fuel weight. So initially speaking, our weight and balance looks pretty good. Okay, so from this point forward, the next thing we jump into is going to be our simplified fuel calculations. Question is, we're at 9:30. How many want to continue? I know this is when we would normally end. So, but I know we started late, so I'm willing to stay longer if you guys want to, but just your guys' call. Doesn't matter.
We just do this.
It's a good ending point if you want to be done before we jump into the simplified. But if you want, we can keep going and jump into simplified to make up for the hour that we didn't have.
I think there's was.
Yeah.
Okay, then that's fine. That's why I asked. So
Just start this up next class or what?
yeah, we would pick up from this point. I'm gonna do just like a video, like showing how to do the simplified. And what I'm basically also gonna do, I'm gonna give you some stuff to review over the next couple of days. I'm also gonna give you the study guide for like the quiz 6 stuff that you need to kind of look at. But I'm also going to give you some flight plans to do up to this point. Okay? Okay. So that's what you can basically expect.
I have a question
Uh-huh.
about the flight planning. You pulled like all the new tires and tasks from SkyWest online. How do we?
But
do
you
that?
won't ever need to be pulling any of it because I will be giving you all of the information.
Okay.
She's like, oh,
That's not gonna happen to me. Who's Patrick doing it?
So we will, yeah. So I'm just gonna. That's what you can expect to get in the email. So I'm gonna send you some flight plans with the information that I told you was basically, ETD, METARs, TAFs, NOTAMs, all that stuff. Kind of just in the PDF file, all of it. I'm going to send you the file for the flight planning packet as well. And then you can just go all the way through the weight and balance with that initial fuel estimate. Okay?
Balance for food, I felt like I'd be more of
There you are, Son, more times.
it.